Welcome to Vision Plus and welcome back to this senior for mathematics and complex numbers. We are now looking at the Argand diagram and we are doing example 2. Example 2 says that we are given three complex numbers Z1, Z2 and Z3, and then they're asking us to represent the following on an Argand diagram. Part A says that we need to represent Z2. So the solution here is for part A, Z2. What is complex number Z2? Z2 is given as 2 minus 3i. So remember, an Argand diagram is it has two axes. It has the vertical axis and the horizontal axis. We are calling the horizontal axis the real axis, and we are calling the vertical axis the imaginary axis. Now we need to mark or label. Now you come and look here. You have 2 and 3. These are small numbers. So you can just mark, just estimate any convenient size that makes your work organized. So I'm going to say from here to here is 1. Then I should maintain the same distance. From here to here, I've said it is 1. So from here to approximately here is 2. Remember the center is always at 0. And then 3 here, and maybe my 4 there. I don't want to congest my numbering, otherwise 1, 3 here, they are there. Then I come and mark here again 1, 2, 3, 4. 1, 2, 3, 4. But this is the negative side of the real axis. This is negative, this is negative. Then you come up 1, 2, 3, 4. 1, 2, 3, 4. Down 1, 2, 3, 4. 1, 2, 3, 4. This is down here. We have the negative imaginary axis values. Now you have represented you have drawn your complex plane. This is called the complex plane. Where you have the real axis and the imaginary axis. Now we need to represent this complex number now so that it becomes the Argand diagram. Remember, this 2 is the real part. It is not containing I. This is the real part of the complex number. So the real part here lies on the real axis. So what do? You just come and look for 2 on the real axis. This positive 2. So we look for positive 2, which is here, not negative 2. It's positive, so it is here. And then you go to the imaginary axis, which is the vertical line, and then you look for negative 3. This sign is for negative 3. This negative 3i. This is y, which is the coefficient of I, negative 3. So on the vertical axis, look for negative 3. Now you know that this is the side for the negatives. It is down here for the imaginary axis. That means negative 1, negative 2, negative 3. You could even mark it here as well, but you don't congest your work. So this is negative 3. So this is positive 2, this is negative 3. So you just elongate this a bit so that you find their point of intersection. This is where they are meeting. This is where positive 2 meets negative 3. Now you need to draw a straight line from the center, from the origin to this point of intersection. So you just get a ruler and then you say, okay, this is my straight line from the center up to that point. Remember, we have emphasized that the complex number is used to represent vector quantities. So it is a sort of a vector quantity. It has the direction. You put an arrow on top here, and then you mark it as I've realized the mistake. The question was saying Z2, but we have substituted here for Z1 instead. So this is not Z2. Instead, it is Z1. So Z1 is the one which is equal to 2 minus 3i. So what can we do here? Let us take it as the solution for part C. So instead of A here, let me change it to part C. Part C was the one asking for Z1, and we have solved Z1 here. I don't want us to erase and we start over again. So let me just mark this one as Z1, which is the complex number 2 minus 3i. And then now that means we are going to do part B, which is Z3, and then we go on and then we do part A, which is Z2. So let us go to part B. Part B says that we need to represent Z3. Part B says we need to represent Z3, which is equal to, now you be careful, Z3 is 4, is 4i plus 4. Always follow what the question has requested for. We made a mistake there, but I hope we have rectified it correctly. Now coming to Z3, which is 4i plus 4, you need to start by drawing your axis. Straight lines, by the way, and then the horizontal axis. This is the imaginary axis, which is the vertical line axis. This is the real. This is the real axis. If you look at your numbers, you have 4 and 4. So you need to mark or label your axis. Like this is the center origin. You may put this big O or 0 there or not. Then you mark 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. This is 1, 2, 3, 4. 1, 2, 3, 4. 4. But this is the negative part of the imaginary axis. 1, 2, 3, 4. This is the negative part of the real axis. 1, 2, 3, 4. That is the positive part of the imaginary axis in that format. Now from here, we need to locate. It doesn't matter whether you start by locating on the imaginary axis first or on the real axis first. So let us start with the real axis first. We come to the real number or the real part of the complex number, which is not containing I, that is 4. So we look for positive 4 on the real axis, for which the positive numbers are here. So this is the positive 4 on the real axis. And then on the imaginary axis also, you are looking for 4. So on the imaginary axis, you look for positive 4, which is here. Then you see where they're meeting. Draw a straight horizontal line, then a straight vertical line, and see where they intersect. This is where they are meeting. This is their point of intersection. What then do? You draw a straight line from the origin to that point of intersection. So the straight line, get a ruler or something approximately straight. By the way, get a ruler, it is a must. You must get a ruler. After drawing that straight line, you put an arrow on the head here, and then you name it. What is that? It is complex number Z3. Let's put right on it here, Z3. That is the complex number on the Argand diagram, and that is the solution for part B. Now going to part A. Remember we have done part C here already, which was Z1. Now we need to do Z2, which is now part A. So part A says that we are finding Z2, and for which Z2 is negative 2 plus I. The good thing with examinations these days is that students are encouraged to do the numbers that they know first, and then they do the ones that require thinking and time later on. So the order of you solving your question doesn't matter, as long as the numbering is very okay. They will be matched. So we start by drawing our axis, that is the vertical axis, which is the imaginary axis. This is the horizontal axis, which is the real axis. But some of you students are very funny. Yes, you are very funny. What do? You find that someone decides to put up here the real axis and puts down here on the horizontal axis, puts the imaginary axis. Please, this is not a diagram. This is an Argand diagram, not yours. And by convention, it was that the horizontal line is the real axis. So take note on that. And then you come in, this center is always the origin or 0. Origin is always at 0. Coordinates 0, 0. Whether in a 2D plane or 3D plane. Now, if you look at your numbers, you have 2 and 1 here. So the biggest number is like 2. So you can space over out a bit. So this is my 1, this is my 2. 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 After reaching the number you want, leave out the rest because this Cartesian plane or the Argand diagram is infinite. This one goes up to positive infinity. Also goes to positive infinity. It is infinite. So let us label. This is 1, 2, 1, 2, 1, 2, 1, 2. Do not forget that down here we have the negative imaginary axis values, and to the left here we have negative real axis values. So those are negative in that format. Now, these students are funny. You find I'm putting the arrow on top here and on this side, on the right side. But you find the student has put an arrow here and has also put an arrow down here. Why are you doing that? Have I done it? No. And the moment you do it, it will be crossed directly. Automatically, you won't get any mark. The arrow is on top and on this side only. Some of you also are fun. You find that you're putting a negative numbers on this side. No. The negatives are to the left and down of their respective axis. Now let us continue. This is the real axis. So you come and look for the real number. Negative 2 is the real part of this complex number Z2, negative 2. So on the real axis here, we are going to look for negative 2, not positive 2, it is negative 2, which is here. So you just note it. And then you go to the imaginary part. Remember there is no number here. So we assume there is positive 1 there. There is positive 1 there. That is the original one. So that means here we shall look for positive 1 on the imaginary axis. Positive parts is up here. So this is positive 1, not negative 1. It is plus I, which is, it means it is plus 1I. So this is the positive 1. Now we're going to look for where this negative 2 of the real axis will intersect with positive 1 of the imaginary axis. So you just draw a guiding line here, dot it. Then you draw the vertical line, dot it. It should be approximately straight, horizontally straight and vertically straight. And then from here, you come and draw. I've said that you must use a ruler. You cannot say, for me I don't have a ruler. You buy a ruler. See me here, I'm having my ruler. So here you draw a straight line from there up to there, from the origin up to the point of intersection. Then you put an arrow on top, and then show us what have you drawn, what complex number have you drawn. There are very many there. If you leave it like that, we shall be confused. So we miss 1 mark for naming what we have drawn. This is Z2. So just put on it here, Z2. In case you don't have space, you can even point at it. Then you write somewhere that this is